I would like to acknowledge the universe for enabling us all to be here at this time. I would like to acknowledge the traditional owners and dwellers of Australia, the stewards of the coral reefs, and all of you as stewards of the planet Earth. So I'm coming to talk about Reefs of Hope. The UNESCO just in February approved Reefs of Hope as a decade action, an ocean decade action. And by doing so, the UN, it's kind of a backdoor, but the UN has endorsed now the very first climate change adaptation program for coral reefs ever that's coral focused. The UN has endorsed it, okay? So it is community-based, it is resort-based, it is science-based, and whoever likes it and wants to participate, it's not exclusive. So basically it's a different approach. So if you like it, maybe you'd like to become part of Reefs of Hope, because we need hope in this world, and it needs to be not false hope. It needs to be very real. Okay? So last year, the global thermostat broke. Nobody can explain what happened, but we went over a tipping point, okay? And it's continuing. Thank goodness. I'm so happy it's leveling off, and it looks like it might follow the 2023 line, we hope. What I think is happening is the overturning circulation is actually collapsing right now. I believe that's happening. This year, the new results just came in. We went over 10 millimeters of sea level rise in 1 year. Global record. Okay, and it looks like it's accelerating very rapidly now. So I'm actually cheering that on, because the more sea level rise we get for corals, the cooler the nearshore reefs will be. Okay? So Earth has her equilibrium. She has a fever, she turns on the fan. That's called a cyclone, okay? And to cool these nearshore reefs, we need the ices to melt. And it's very sad because human beings then are impacted. Okay? So this is the graph on the left, on your left, is the Great Barrier Reef. And what we're experiencing right now in the southern Great Barrier Reef is the dark black line. We've had record heat stress. These are all the years, the bleaching stress levels, right? So the black line shows that we've had record stress in the southern Great Barrier Reef. And the other one is what Cuba just experienced. Cuba experienced something much worse. And what I'm saying to you guys here in the Great Barrier Reef is that our days are numbered, that we can expect degree heating wakes of 20 and above. Florida got, I think, 24 or 25 degree heating weeks, and that's why everything died. Okay, so we have to ask this question. What are our reefs going to look like in 10, 20 years? When we get a 20-degree heating week and above, we can expect almost every coral you're planting right now will die. Okay? This is reality. This is not very hopeful. Okay? But this is your reality. I experienced it. Everything I planted died. And I've been doing this for over 35 years now. So I think I've been doing coral work longer than anybody here. Okay? So this is our Fiji site. We had the most amazing thing. The BBC TV came and did a special called The Coral Gardener. We were on 3 BBC programs. Every coral we planted died. It tore my heart out. And your heart's going to be broken. It's going to be torn out of your body. You're going to feel horrible. You're going to weep. And I don't want to scare you, but I do want to scare you, because you can do something about it now. Okay? Now, this is where I learned my lesson. My corals had died in Fiji. I went to Christmas Island, Christmas, in the Line Islands. It's an atoll, right? And it's quite a big place. I arrived there in 2016 after the 27-degree heating weeks had hit. We searched for days and days to find corals. All the acroporas were dead. All the Poeciloporas were dead. Even the Porites had died. Can you believe that? Okay? So it was really very depressing. And since then, most of the fish have become poisonous with ciguatera as well. It's directly related to the decline of the reefs. So I realized at that point that if I had just gotten there the year before, inside the lagoon were corals that could survive at a much higher temperature. I could have moved them out. They're the same species, but nobody did. So all our most adapted corals died because nobody did anything. I'm looking at the Great Barrier Reef, and your most adapted corals are right in that same position of being wiped out when it gets to 38. That's what happened in Florida. It got up to 38.4, okay? So we have coral populations right now that are in grave danger of being wiped out. Actually, all of our coral populations, but the heat-adapted corals are the ones we have to focus on. So this is the lagoon inside Christmas Atoll, and we looked and looked and looked. I found one little bit of Montipora, one little bit. That's all I saw after days. So we looked for 4 days. Finally, we found a little bit of Acropora. What is it called? Anyway, never mind the name. So we found one little fist-sized piece of coral. I was so excited. Right up against the island by a bird colony. And I'm thinking, well, maybe the bird poop was phosphorus, rich in something they needed. And we found one tiny little, looked like a new sexual recruit on a stone. After 4 days, that's all we could find, looking all day long. Okay? The beach is full of tabulate corals. We know that tabulate corals are very important to their history. They build churches and school buildings out of them. Not a single colony left, extinct on the island of Christmas Atoll, right? So Kiribati, the nation of Kiribati, is the front line of the collapse of coral reefs globally. They have had the most stress of anywhere on the planet. They're on the equator. Mother Earth can't turn on the fan there. It's broken. Cyclones do not form on the equator, okay? So the lessons we need to learn to save your reefs are right there, right now. We can go in a time machine just by going on the airplane, okay? Seriously, we need to really embrace these realities. Okay, now I made this from, I don't know if you can see that, but from the NOAA data. I just went through the NOAA data and counted the number of stress events for each of these points. And these are not really detailed data because it's like 1 point for all of Fiji. Sometimes the eastern side dies, and sometimes the western side, and sometimes the south and the north. And it just puts them all together and calls it condition 3 or condition 4, whatever. So also NOAA has changed their ratings. They've added condition 3, 4, and 5. So condition 1 is green. Okay, I love condition 1 bleaching. When condition 1 bleaching comes to your reef, I celebrate because that's an educational event. Don't worry about it. It's a condition 1, okay? The corals are going to learn how to adapt. You get year after year of condition 1, your coral reefs can learn to adapt better. Condition 2 is yellow. Condition 2, you get a little bit of mortality, but that's probably still good because the weaker guys will survive, and most of the corals still survive. Then when you get to the condition 3, the red ones, and condition 4 is gray, and condition 5 is black, that's when you have an extinction event locally. And that's when, if you had moved corals, you'll still have them, okay? As long as you can find heat-adapted corals, you'll still have them. Okay, so these heat-adapted corals that you'll have in your nearshore areas are on these big flat reef flats. You know, there's really extensive reef flats. They get really shallow at low tide. They are vulnerable to heat. They're jeopardized. So we have to recognize that those are precious resources. They have spent thousands of years evolving heat tolerance, and we need to protect them, okay? This is a very different strategy than what I'm hearing from the Great Barrier Reef right here today, okay? It's a very different strategy. And I'm just saying it's something you can encompass, and no matter what you're doing, no matter what methods you're using, if you access those wonderful corals that have learned over thousands of years, whatever you're doing, incorporate that into your methods and continue, okay? If you're breeding corals, if you're planting corals, if you're doing nurseries, all it takes is a very simple step of locating the very strongest corals, okay? So the acroporas are the most vulnerable, and this is the one that we need to focus on. And so what happens on the reef, and it's already happening in the Torres Strait, is when you have multiple layers of stress, you go from acropora-dominated reefs, this is say on the outer reef, you know, normally where a cropper belongs. A cropper is replaced, and it can be replaced by Pocillopora if it's lots of crown of thorns, because Pocillopora is resilient. It has little animals that bite the crown of thorns. So that's my hypothesis anyway, and people have shown that. So, and then it ends up going to either, the end state is Porites and Montipora, and maybe if it continues like Christmas Island, even those can be wiped out. So there's a stepwise, I see it happen all over the place, and there's a stepwise decline, and we need to recognize that. So if we recognize it's happening, we can also then, so if you're talking about coral cover is a very bad measurement for actually indicating coral reef decline. It might be good kind of superficially, but they'll call it recovered when it's all Porites. They'll call it recovered. It's not recovered. It's a completely different state, okay? And will the same fish be there? You know, if you're a fisherman in the Torres Strait Island and you have all these round Porites, where are the fish going to live? The little chromis don't live there, okay? They don't even live in tabulate corals. They live in the staghorns and digitates, right? So depending upon the corals on the reef will be the fish. I better keep going up. So, okay, so the open ocean in Christmas Island during that 27-degree heating weeks never got above 33, okay? It got to 32 only. I'm assuming that no matter what happens with climate change, that ocean, that deep ocean, is never going to get hotter than 33. And maybe my assumption's wrong, but I think I'm probably right, okay? So we need some oceanographers to confirm that. That some those outer reef areas that you plant corals to will never go, even as it's close on the outer reef, will never get hotter than 33 or 34. That the hot pocket corals that you're getting can survive 34, so just move them. They're going to be fine. So we have a tremendous amount of hope because Mother Nature has already pre-selected the adapted corals that we need to use. We don't have to do too much fancy science. We just have to have really good thermal readings from the near shore. And we have to collect these systematically, okay? And so when you're collecting those thermally tolerant corals, you're going to also collect the algae, the bacteria, whatever makes them thermally tolerant. You've got the whole holobiont and bring it out. Some people say, well, don't put it right into the cold water right away. Well, maybe there's a moderate place. All you need to do is move it to where it's a couple degrees cooler. And then maybe when those grow big, you move some further out. We don't know if they're going to revert into, if they're going to lose their heat adaptation. So be smart about it. Okay, so this new restoration paradigm is to secure those heat-adapted corals. Then you grow them up in your nurseries, and you create a gene bank nursery, okay? They're together here. If you want to you have your heat-adapted corals in this beautiful nursery, you can now collect the larvae if you like, okay? Or whatever you want to do. Or you can trim them. And then those second generation, we are doing a different way. We're creating dense patches of coral. So what we do is we grow them on ropes big. In a year, the staghorns get big. We basically cut that rope up once a year, and we take one of them and refragmenting and put the genotype back in the nursery, and all those other colonies, we plant them out in patches. We want big colonies. Why? Because we want fish. Why do we want fish? Because fish reboot the entire ecosystem. They clean around the corals. They make the rubble, or not rubble, the rock clean and ready for the larvae to settle. So this is a whole different paradigm, these nucleation patches. And then the corals, the acropers have a smell. We've all smelled it. That is a special protein, basically, that coral larvae cannot resist. Coral larvae, it's been proven by the Japanese scientists that the corals will come in, and when they smell that, they want to settle. So you have an odor cue, it's a pheromone. You also, pink, corals have been proven that corals like pink. And they even don't have eyes, they can sense pink and they settle on pink. There's another paper on that. I have a paper called Reefs of Hope. And it was, we can assess it. So search Reefs of Hope and you'll find a link to my paper and some films. So they can see pink, coral and algae's pink. The fish in the corals will clean up around there and you'll have more pink. Okay, so they're seeing that patch. And also, if you have Polypora in there especially, they will hear it. The Polypora are quite noisy with all the little things inside them. So we're looking at trying to get the corals to regenerate themselves. And if you look on a really dead reef and you see a recovery, it's happening in patches. That's what I'm seeing. Usually you'll see a patch. And that patch, oh, here's some corals. And look inside that patch. You might find some big acropers in there that were the nucleation, like a crystal, crystal nucleation. Okay. So these are the hot pockets in Fiji. We got the whole northern side of Vanuatu and also Viti Levu, where it can get over 37 and there's still corals, okay? believe it or not. Okay? This hot pocket here is north of Lautoka, and it still has corals, and you can imagine the amazing resilience they would have in those shallow areas. There's plenty of areas on the Great Barrier Reef that look like that. So you've got all these precious corals that need to be rescued. This is our main site in the Mamanuca Islands, and we have a double barrier reef system. So we have, I call Papa Bear, Baby Bear, and Mama Bear. So Baby Bear's porridge is too hot. I'm moving them out, okay? And moving them to Papa Bear is cold. And so we have our gene bank nursery is on the second reef, where it's moderately stressed, just to make sure that we maintain that resistance. And last year, La Nina, the winds reversed, and the hot water came over our site. For over a month, it was 32, and it peaked to 33 on 3 days. So everything in our nursery was exposed to hot water, and we had to retire 27 genotypes, but we had over 100 genotypes that are strong, okay? So this is the Nuco Reef. The middle barrier reef is doing better than the outer barrier reef. The outer barrier reef mostly died because the corals were cool adapted. The inner barrier reef is now Porites dominated, and the croppers can't even find a place to settle, and the crown of thorns eat them so badly. The middle barrier reef is fine, okay? And this is one of the gene bank nurseries, and so typically one line will be one genotype, okay? And so this was a testing nursery, near shore, hotter water, and you can see it got 34 here, and 2 of our genotypes that we thought were good turned out not to be so good. And so we do a testing nursery as well. If you do it right, you'll have a testing nursery in hotter water to screen them, okay? And then this is the other thing we do. If the corals are already dead in the hot pockets, or it's a place like Kiribati, we have to find the corals that are surviving the bleaching, because these predators will jump on them. The acropora there was one of the few acroporas we found in Kiribati, and those snails are from that acropora. We had 85 snails on one colony, and that was the only colony left. And we saved its life, okay? Barely, okay? Butterfly fish, voracious if you have acropora, and that's the only acropora there. They'll just strip the tissues off. Parrotfish, oh my goodness, the parrotfish can devour corals. So parrotfish, once you have a very low abundance of acropora, it's their ice cream, and they will all come and they will wipe it out. I've tried restoring those reefs. The corals we grew in Kiribati, we planted them, disappear. Okay, the parrotfish eat them right up. Okay, so this is our nursery here. We've got to have a gene bank, and it turns out when you move a coral into a gene bank, with our methods on these metal tables with ropes, crown of thorns can't find them. No matter how many crown of thorns are there, they can't find them. The snails can't crawl onto them. Now and then you'll get a few snails settling in from the larvae. But, and the butterfly fish and parrotfish don't seem to like them either. They're on these ropes. So they seem to be more resilient to every predator, okay? And we also have this cookie method on the tables, and that works very well. And I want to point one more thing out. We found out that these farmer fish, these Stegastes damselfish, are our best friend. When we have very low acropora abundance, from whatever reason, if we're going to find a cropper, it's going to be in these farmer fish territories. So they're maintaining, because they chase away the crown of thorns, they will absolutely chase away the butterfly fish, the parrotfish, and even this horrible Lingbia algae. We had a big problem in our nursery one time when this cyanobacteria just clogged our whole nursery, and we didn't know what to do. And so we found out that if we untie the rope and put it in the farmer fish territory, within 24 hours they clean it just as clean as can be. They hate that algae and they weed it. So then we put it back in the nursery. Okay? So, and if you want to do coral work in the summertime or when there's high UV, shade cloth, no bleaching whatsoever. So we continue to do our work in the summer now. I had a workshop, and I said, how are we going to do a workshop? How can we teach these methods? This is not the time of year for that. So we did everything under the shade. It was fine. Okay? And this is the first coral nursery that I know of that was created at the very tail end of a bleaching, when we had 99% bleached reef in Moturiki. And I trained these 5 village guys, indigenous guys, to go out and say, okay, this is alive, this is dead, this is bleached, this is an unbleached coral. I found one. And I said, can you find this? And we filled the whole nursery up full of corals that were either totally unbleached or very slightly bleached. And this was exciting. It took 1 day to make this nursery. Now we have corals that we know are resistant that we can work with. So use the bleaching as your advantage. Okay? So this is, Reefs of Hope is the first UN-endorsed climate change adaptation strategy. How much time do I have? Okay, so it focuses on coral species survival. So instead of, okay, here our house is on fire. You got babies in the bed. Okay, are you gonna stay in there and keep repairing your linoleum floor? Or fixing the cabinet? Or washing the curtains? No, you have to get out of that house. So imagine this is like a city of houses that are on fire in the near shore and houses that maybe those kids will die because of something else. But we can move our babies out of the house and help them. I don't know what I'm doing. Okay. So we're looking more on the survival of species into the future than we are in restoration. I think the time of restoration is finished because what's coming at us is like a giant bus, and we got to get out of the road. We got to get our kids out of the road. So the time for normal restoration it can continue as long as you get the right stock, okay? And so if you want to continue as you are, if you don't know about the resistance of your corals, I'm just telling you, you're going to lose everything, okay? I'm just warning you. I don't want you to cry and go through what I went through. This is really important. So we have a new way also of outplanting, and that's patch nucleation. I learned that from tropical forest restoration. So anyway, we're also looking at the communities and the resorts that depend upon the reefs, and we're putting them in the forefront. That's what they really like about, okay, wait. Okay, so we have some really good progress in the South Pacific. We have in Fiji over 300 community-based no fishing areas. It's amazing progress. There was none in the year 2000. That's where they first started, okay? And it was restoring their traditional culture that brought those back, okay? That we have really wonderful government support, and they give us giant clams that they're in from their hatchery for the no fishing areas, and that's happening, and that's really good. It's really encouraging. We have over 600 Pacific Islanders, mostly Fijians, who have graduated from the University of South Pacific. We have 600 indigenous marine biologists, and most of them have no jobs, okay? We're considering this a resource, right? And then we have also a Tete live how to make virgin coconut oil, take cocoa and make chocolate out of it. We have a happy chicken product. Celia, raise your hand. There's Celia. We have an NGO partner in Australia. Celia's there. And she started with the chickens because she was a chicken expert and we needed her help. So they helped fund our hatchery. We've produced over 50,000 baby chickens, giving to communities that are setting aside no fishing areas, okay? And this is the approach we have to look at. We have to look at the well-being of the people that are using the reef. If people have no other way of income, they're going to overfish the reef, or their food source. We have to look at the wholeness, the oneness of these communities that depend upon those reefs. And the tourism industry is important too, but the communities will be there even if the tourism closes. Okay, so here's the model, very quickly. We have this army that we want to create of these trained marine biologists. And then we're going to send, the tourism industry wants to take about 100 of them. We figure there's so much demand for these. They want a coral gardening program in every resort in Fiji. They do. So they got jobs now because we've trained them, okay? We've already created jobs for about 20 people so far, okay? We have this training program, and then the rest of them, the other 200 or 300, will go into the villages and live among the people working with the no fishing areas, working with the communities. And we're hoping it's going to spill over to Samoa, Kiribati, everywhere. Okay, so the resorts are hiring. These are Sarah and Kaleni. They were hired by the Plantation Island Resort, doing a great job, and that's our primary site. So I don't have to look out for it. The resort lets these staff look out for it. Okay, DFAT and WWF Australia funded this workshop. We did this beautiful workshop, and these are marine biologists. Most of them are tourism industry people. Last year I trained over 100 people. And so this is Reefs of Hope, getting the power in the hands of the communities and the indigenous communities who, those reefs, they're their custodians. And this is really amazing work, okay? It's so good, feels so good, it's so good. We're just so happy because people now have power and they have hope, and it's not a false hope. And the main thing is we have to teach them to select the heat-adapted corals, okay? We're gonna get the children, we do get the children involved. And we have all these sites now in Kiribati. I just came back from Kiribati, Tuvalu, Samoa, Vanuatu. Okay, this is Tuvalu last November. Now, if I go back here, it'll all be nothing but dead coral, because Tuvalu had just now a condition 3 bleaching when they only had very little experience. So we moved the corals out. we put them in the coolest place we could find. And because it's up current, this is what we expect. We want to, even though most of the corals are dead, the ones we moved, we hope they're still alive. We're going to go check, and then they're going to reseed the whole lagoon. Okay? So we have to reinvent coral restoration. Okay? I'm going to skip that one. Okay? This is what we've done. This is how they restore reefs. Instead of planting little, the old model was like pine forest restoration, like for forestry, where you put all these little things around. They don't do that anymore because they found out the mortality is too high. What they do now with the restoration of forests in the tropics, they grow 3-meter high trees, fewer of them. And so instead of planting 10,000 little ones, if they plant just 100 big ones, they get so much better success. And they won't just randomly plant them. They'll plant them in an area the size of this room to create a patch. And they found that the birds regenerate the whole system. Those birds, you have to put it in visual distance of a forest patch. The birds will fly, sit on there, poop, eat the bugs, make their nests, and as they fly, they bring and they poop their seeds, and the seeds start to grow. And if you use even one species, within 50 years, you'll have 100 species there, and the whole patch is growing. So this is how the rainforest restores itself, and I believe that if people would study, they're going to find that it's also recovering based on patch dynamics. And the fish are the birds of the reef. Okay? Okay, so anyway, so I don't think, but this is instead of planting we were doing big colonies, and now we're thinking, oh golly, we want to involve the children and the youth because they're so important, the next generation. So now what we do is we trim our corals and break them up. We bring them in. These are epoxy coated, just the metal frames, and we plant these A-frames. I'm almost finished. And with the kids, because the kids have planted all our corals now. So instead of us planting the corals, we want the children to plant the corals. And they can grow on sand, rubble, whatever. We weight them according to the currents. And this is 2 years old. And this is the last picture. This is what the people are so excited about their no fishing areas because we're actually creating amazing fish habitat structures as we're creating adaptation and restoration. So it's a holistic thing, and that's enough.